this number right here. Click add. Voila.
So you can essentially just use that to find all your names.
Yep.
If you wanted to.
Yep. That's pretty useful. Personally, I like to enter them up here because it's a little bit faster, but
Yeah.
absolutely. There's one other thing that you can do, which is if you list the names in a table format, and then you drag all of them, or if you select all of them, you can go to Insert, Name, Create, and it will make a guess at saying, okay, I think the names are going to be here, and I think the values are going to be here. Is that correct? And that's what it's asking. It's saying, oh, I think the names are in the left column. Yeah, okay, great. Click OK, and then suddenly if you select the cell that is name 1, name 1. So that's another way to quickly enter names for Excel. Other questions on names? There. Cool. We're going to change gears and talk about tornado diagrams, which are an expansion of the scenarios and allow you to look at what parameters affect your model the most. So in this case, we're looking at. Yep.
I need to bail out because I got another meeting.
Sure.
But I'll be back this afternoon. You know, upstairs.
Okay.
And are we cool on this GSB thing?
I haven't seen an email if you sent it in the last 2 hours.
I sent it this morning. I sent it to Mike Opie and you.
Oh, then I haven't read it yet.
But anyway, they just proposed either the 5th or the 7th. As alternatives.
Okay.
No, there's no point waiting until after this work.
Yep. All right. Well, we'll talk.
Thanks for doing this.
So we're going to go to a different model now. This one was from another class of decision analysis. It was looking at a company that was producing a product and wanted to, you needed to like build a decision program for it. It was very complicated. But I'm going to use it to illustrate a couple of neat points. So the basics of it are that you have some constants like the discount rate and the sales price. And then you have some uncertainties like how many times this product is going to fail and needs to be repaired, or the number of machines that are actually sold, or the training costs. Now note again that this is a very similar setup to what I showed you before. Very powerful. I've seen it across all different kinds of classes. Very common format. In this case, we chose to put the name next to the cell for ease of reference. Now you can play with all these scenarios, but some of them are obviously going to have a bigger impact than others. And that's where we get to tornado diagrams. How many of you are familiar with tornado diagrams? Okay. So essentially what a tornado diagram does is it says, okay, grab one parameter, set it to low, base, and high, and record the values. Grab another parameter, set it to low, base, high, and record the values. Do that for all of them. And then look at, okay, what causes the biggest swing in the output number, such as the profit. And then you sort it in such a way that it becomes a little bit more clear. So this is the end result of a tornado diagram. So you see here that for this particular case, the repair cost for a certain product causes the biggest swing when you set it to low or high. And then for this particular case, the training costs has no impact at all. This is really useful for you because you'll have a whole lot of uncertainties, a lot of parameters that you're just mucking around with. And some of them are actually going to matter and some of them won't. It's best to not worry about the ones that don't matter and to say, oh, that's a certain number, and it's really not worth looking into it more because it's not going to have much of an impact. That's the high-level view of tornado diagrams. To set that up, can use a data table to create the outputs, or you can just manually enter them, or you can use VBA, which we'll talk about a little bit later. But essentially, your goal is to list every uncertainty and then list the, in this case, the net present value for each setting. Oops. So in this case, for the average repair cost for alpha, you set it to low, everything else is set to base, and you get negative 88. Set it to base, it's negative 109, et cetera, et cetera. Once you have all these values, then you compute what we call the swing. The swing is the maximum range of numbers that can change. You square that, and you take the sum, and this number represents the total variance that you're going to be looking at in your model. In this case, 90,000 square dollars. Doesn't really make much sense, but
Why do you have to square?
to be honest, I don't know. But it has something to do with variance and distributions, and I don't know. That's what was told to me, and that's what I do, and it works. So I call it good. So once you have the total variance, then you can say, okay, what contribution does each variable make to the total variance? So this is called percent variance, which is essentially just dividing the swing squared by the total swing squared, the sum of it, and that gives you some percentage. So you'll notice that this one's 58%, which means that average repair cost beta failure is causing a huge swing. And then you could also include a cumulative column to just make sure that to look at the cumulative.
So you said, like, let's just say average repair cost, alpha failure, value base, right? So you're putting in the base value for that alpha failure, and everything else remains at a base.
Yep.
So in every single one of these situations here, whether it's high, base, or low, everything else, all the other factors are at base.
Yep.
Okay.
Yep. Which is again a limitation.
Oh yeah. Well, at least start somewhere.
But you gotta start somewhere. Yeah. So that's absolutely true. And just remember that these are the outputs, not the value for the base of machines sold. Because that's something else. That's obviously not negative 109. This is the net present value, if you set it for that. So are we clear on how to do percent variance? How'd your hand say yes? Beautiful. Okay, so once you do that, then it's pretty much formatting at that point. You can copy the table over and sort it by variance. So now you'll see that they're sorted by variance. And then you create a graph. So I have all of these values, so I'm going to collect them. I'll go to charts and select bar graph, clustered bar. This produces something like this, which is useless. So, first thing you want to do is make sure that you know what your titles are. So you can go to select the chart data range, or you could right-click it and say select data. There's a variety of ways to get to it. But essentially you want to name those series so you actually know what you're talking about. So series 3 is the I column right here, so that's high. So that's high. Series 2 then is the base. Series 1 is the low. Then we're going to have them stack so that it looks cleaner. So you can double click the data columns, go to overlap, and set that to 100%. Looks kind of ugly at this moment, but we're going to make that fixed. You do this by double clicking on the vertical axis, and you set, excuse me, not the vertical axis. You double click on the horizontal axis and you set what the base value is. Because remember, you're looking at the swing from a certain base value. In this case, that base value is negative 109.5. So we say that the vertical axis crosses at negative 109.5. And voila, suddenly we have a graph that we're somewhat familiar with. Seal the deal by double clicking on the vertical axis and saying categories in reverse order, which then sorts them by the correct range. And you have yourself a tornado diagram. Ta-da! Why is this useful? Your thoughts?
Shows the dispersion of data versus parameters. So it shows you which one can give you a huge upside and which one can give you a huge downside.
It's a more visual way to see the sensitivity analysis.
Yeah.
So the points are actually being graphed. What, I think I missed, so you squared it, and then what's actually being graphed? It's not the square.
The percent of variance.
It's percent of the square.
Yeah.
Could you demonstrate how to do the data tables, how to run the data tables?
For the tornado diagrams?
Yeah.
I will.
One time. Do we?
Let's see. 11:50. Let me pull up. I did this with VBA, which probably get it.
How do you do that?
I'll explain this. I just need to take a look at it.
No, I mean, how do you move your windows by just clicking in the middle?
Oh, that's a program that I have called G-Touch. It allows other gestures that allow you to resize things and move them.
It's very useful to say.
Yeah, I really like it.
Back to that.
Is it for free?
No, it costs like $4. It's spelled J-I-Touch, and I really love it. It was like some of the best $4 I've ever spent on a computer.
Yeah, it seems very useful.
Yep. Very handy. Okay. So let's talk about VBA. To get to your Visual Basic in Mac, you go to Developer, and then you click on Mac, Editor. And then that pulls up this editing space right here. This is like your VBA editor model space. And it exists within the Excel program. This is where you can type up all of your code. So I'll create a new function. And when you start a new VBA thing, you'll just see a blank page. So you create a new function by saying sub and then the name of it. So I'll call this function tornadoes and then open parenthesis and parenthesis. And suddenly I have a new program. Ta-da! Let's skip some of this. Okay. So I'll try to give a preview essentially of what the program does and then really explain how to actually do it. So the goal is to create a space in our VBA code. We'll call this net present value table, where you'll have the outputs go to. So you'll say, okay, set x to low, put it in here. Set x to base, put it in here. Set x to high, put it in here. Set y to da 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 da. So you have to specify that. And then you also have to specify what you're going to be changing. So there are a couple of useful functions. The first one is dim. Variable. As. And then you specify what it's going to be. It could be a string, which would be a name. It could be a double, which is like pretty much any number that you'll ever have to deal with. Or it could be an integer. These are the common variable types that you'll deal with. Integer, double, and string. So this is a line of code. So you could say dim net present value table and you could specify that it's actually a matrix with parenthesis and parenthesis as double. So that's the first thing. It'll make more sense when I actually show the real code. The second thing is what we call a for loop, which essentially says while a certain criteria is being met, repeat this cycle. Okay.
Sorry, I wasn't able to program you have to size the windows.
G-Touch. J-I touch.
Is it in the App Store?
I don't think so, but if you Google it, you can find it.
Okay, thank you.
No problem. So we're going to dim our net present value table. And in this case, we have 6 uncertainties with 3 columns as double. Now we've created a table in that space. We're going to need a for loop, so we'll need a variable to go along with it. So I'll say dim I as a counter as an integer. And I will say which uncertainty are we looking at. So then I'll create a loop. And the format is for and then the criteria. So 4 equals 1 to 6. That says run this repeatedly for every, when I is between 1 and 6. And you'll do some stuff here, and then at the end of it you'll say next I, which means increase it by 1.
Is there an end statement for for loops?
No, there are no end statements for loops. And I'm also going to create a dimension called uncertainty. And that's going to be the name of the uncertainty that we're changing. So the first thing I do is essentially say, okay, what's the name of the uncertainty going to be? Well, if I is equal to 1, then I'm looking at repair cost alpha. If I is equal to 2, it's going to be repair cost beta. 3 is alpha failures, 4 is beta failures, etc., etc. There are more elegant ways to do it, but this is a pretty simple way, and it's just using if statements and else if statements. Does this make sense to people? Cool. And I can share the code with you afterwards, so you can just break down. So once I have the uncertainty specified, then I need to say, I need to vary the low, base, and high values. So I create another integer or another loop within that for loop. And I say for count 1 to 3. And then I do some magic here that essentially says, set the index number to the count, and then record the net present value. So I'll break this down a little bit. Initially we have I is equal to 1, repair cost alpha, and count is equal to 1 for low. I use this function here called range.cells that essentially takes a range from the Excel formula and puts in a number. In this case, I've set it up so that the name of the uncertainty is also the name of the cell. So when I called uncertainty repair cost alpha, then I say set the cell that's called repair cost alpha to the number that I'm looking at, 1, 2, or 3. This dot cells allows you to change a number relative to it. So if we have our data table here, or this is living in Excel. And let's say this one is called A, or AND. Why? It's called A. And so I can say range, and then parenthesis Andy, and that would be changing this. But let's say I don't want to change that. I actually want to change the one that's right next to it. That's where the dot cells option comes in. So the address of this is 1, 1. This is the row and a column. So this would be what? 1, 2, 2, 1, 2, 2. Okay. What about these?
Minus 1,
Almost. It's 0, 1, and 0, 2. And then it goes up to minus 1, 1, minus 1, 2. So then if we could just return to that function where I said change the range that's named after the uncertainty. But I'm not actually going to change that. I'm going to change the cell that's in that row and 2 columns to the left of it. So if I go to that spot, I'll show what I mean by that. So here are the values. You'll notice that these are the in-use values, so the uncertainty is by that name. So it says, okay, well here's the repair cost alpha, but I don't want to change that because that's actually reading a number. I want to change the index, which is in the same row and 2 columns to the left of it. And that's why it's 1 minus 2. It's essentially a way of trying to get at whatever variables you want to change. Does that make sense to people? Roughly?
So you're just basically going down the list.
Yep. And then you do next count. And then at the very end you can also set it so that it resets the values, which is probably a good idea.
So there's no functionality in Excel that do all this without media.
Unfortunately, no.
No.
No. And this is, I mean, like, this would be useful if you have, say, like, more than 6 uncertainties that you're interested in. If you have 5, that's 15 times you'd have to change something and then write it down. Fairly reasonable, and if you're only going to do this once, that might be the best option. But if you're really interested in learning VBA and using this as a tool later on, this is a great way to start. And personally, I think that it's a very, like, I used to think that it was totally useless. I was like, whatever, I can do everything in Excel. And then this class taught me that I couldn't do everything in Excel, and that I need VBA.
Is there advantage to using like Excel plus VBA versus MATLAB or whatever?
For me, the advantage is that I don't know MATLAB.
Okay. So it's whatever, really whatever you're most comfortable with.
Exactly. Yeah. MATLAB would be perfectly fine. But it might be a little bit more difficult to create the user interface to go along with it. So again, essentially what it does is it says, okay, let's look at repair cost alpha, and then we go through that loop 1, 2, 3, and then at the end of that loop, we reset it to 2 so that when we go to the next uncertainty, that this is back to 2 rather than being stuck at 3. And then as you do this, you will plug the net present value numbers into your net present value table. So you set the uncertainty index, you grab the net present value number, you throw it into the table, you go on to the next one. You do that, it does this automatically, and then at the very end of the day, you output that to some table in Excel. Which you can do with this. So all I'm doing here is I'm saying, okay, grab the net present value table, which we've already specified here, and put it into what I've named as a range called Tornado 1 in Excel. Just put those numbers in. You've got your net present value numbers.
What does that give you? What does the table look like?
That table would look like this. Notice that these are the lowercase highs, and that one's called Tornado 1. So that's your very rough and rushed introduction into VBA. It's kind of a doozy. Other questions on that material? So there's a lot more you can do with it. You can take those variables and then say, okay, we'll create this probabilistic model, which is really handy and a lot of analysis. And to me, it's quite interesting, but probably beyond the scope of this class. For what this gives you with the tornado diagram, you can present this to an investor and say, look at how much we're affected by this uncertainty. This is what we really need to control. And this is what we're doing to control it. Let's say that's market demand. And we're going to invest very heavily in our marketing strategy. Or we're going to buy options on gas now because the price of gasoline in the future is going to heavily influence our business. So essentially, the tornado diagram allows you to create strategy for mitigating risk and reducing uncertainty in your model.
I don't know how much you know this. I think our feeling is this is probably really useful internally. So as long as you can understand what you're doing to get a little bit better feel of what's going to change what. I don't know if you know, maybe we should talk to Professor Rumler about do investors want to see this? Are they going to understand the tornado diagram? Are they going to be used to seeing that? Or are they just going to go by their own kind of rule of thumb? Oh, I think it's going to be this, and I don't really care what it is.
Yeah. The question of whether investors will be able to understand the tornado diagram is, I think, a really great one for Professor Rumler. it absolutely is true that it's useful internally. And I'd say, if anything, you could translate it into an assessment of risk, because investors certainly know that. And you could say, one of the risks is market demand. It has a huge impact, and this is what we're going to do to change it. And then if they ask, like, well, how do you know that? Then you can whip up your tornado diagram and say, well, we have assessed that it's going to have this impact. Cool. Well, if you have any other questions, feel free to email me. I'll send out the code.